So this will be the last section we do on matrices. It's 4.4. We're slowly kind of still working in the very basics of what matrices are and how they work. There's actually an entire class that you can take on matrices called linear algebra, but nothing that we offer in high school. But this will be the last little piece that we're going to add to matrices, and it's called determinants. So what is a determinant of a matrix? So let's first talk about specifically 2 by 2 matrices. So the determinant of a matrix A, like A, B, C, D, we've seen this before, is denoted by what looks like an absolute value sign. So it kind of is absolute value, but in this case we call this the determinant of A. And so it's defined by, instead of putting those straight bars around A, we can put it around the A, B, C, D as the matrix, the 2 by 2 matrix. And what you do is you take A times D. So we take these two numbers and we multiply them together. And then we subtract that from any other guesses that we have, whatever we have left. That would be C and B. Those two. So we take A times D and we subtract it from CB. That will give you a number, and that also gives you the determinant. So that's one of the things we're going to practice is only working with 2 by 2 matrices and trying to find the determinant. Determinants are useful in solving systems of equations and something that we're going to talk about a little bit today, inverses. So if you remember not that long ago, we were solving equations like this for x and y. You can actually use determinants and matrices to solve these equations. Even when we did the xy, remember we had like a plus z in there, or like a minus 3z, and we had another equation going on. You can use matrices there to solve for x, y, and z, and that as well. We won't cover that. We don't have time to, and we're not in school to do that because it requires the use of the calculator as well. But we're just slowly touching the foundation of what a matrix is, and now we're going to talk about determinants of a matrix. So we're going to practice some. Find the determinants. So they already have the vertical bars next to them. So it says find the determinant. This is the determinant. We're going to do 5 times 3 minus 2 times 7. Remember, multiply first, then we can subtract. 15 minus 14 equals 1. So that is the determinant of that matrix. That's it. And we're not really going to apply what that means in this lesson. We're just going to cut it nice and short and easy. Just find determinants. So the next one, again, do the crisscross here. We're going to do 4 times 6 minus 5 times 8. So what do we get? 24 minus 40, which equals negative 16. And we can have some negatives in there, so don't forget when you multiply these together, you could get positive or negative numbers. So negative 4, negative 5. Oh man, messed that up. Negative 4 times negative 5 minus negative 2 times negative 1. So be careful there. Let me see if I can. Negative 2 and positive 1. So this part here becomes a positive 20 minus, don't forget, we have a negative 2 times 1, which is a negative 2. So this will also turn into a plus, and we get 22. That's it. We find determinants. Do some more. Multiply these together and subtract by these. So we have, I'm going to do this all in one step now. Well, without writing out both answers. 1 times 2 is 2. Minus negative 8 and negative 3 together make a positive 24. So 2 minus 24 is negative 22. All right, how about we do some fractions? Multiply these together. 1/5 times 5 minus a negative 6 times 1/6. If you know how to multiply fractions, it's not so bad. We would do 5 over 1 to go across the top and across the bottom. So this is 5 over 5. Minus, same thing here. Negative 6 times 1 is negative 6. The bottom happens to stay 6. And to simplify this, put parentheses around there, we have 1, negative and negative turns to a plus. 6 over 6 is also 1, so our answer is 2. And the last one, all fractions. Multiply these together, we have 2/3 times 3/4 minus negative 1/2 times 1/3. So if you notice that there you have two negatives here, you can immediately just change it to a plus. But I'll do that in the next step. For multiplying fractions, again, go across the top and bottom. So the top here will be 6, the bottom will be 12. Negative and negative turns to a plus sign. And then top here we have 1, the bottom is 6. The only thing we really can't do to put these together is that we can't just add them the way they are. When you add fractions, you have to have a common denominator, so we have to do one extra step. We can make them both into 12s by multiplying this fraction here. Now change colors. By 2 over 2. Because if you notice, 6 times 2 is 12. So you got to do it to the top and bottom. So my new fraction would be 2 over 12, and we're adding that to 6 over 12. The way you add fractions is you do the top 2, add them, get 8, keep the bottom the same. So 8 over 12, that can also be reduced to 2/3. And that would be your determinant. So there is a huddle problem that you can do. A thinks it's A, B, C. Yep. Just doing the determinant of 2 by 2. Then we're going to move on to a 3 by 3, which is a little bit harder. So determinant of a 3 by 3 matrix. To do the determinant of matrix B, so you see we have a 3 by 3. A, B, C, D, E, F, A, G, H. Notice they didn't put an I there. A, B, C, D, E, F, G, H, J is denoted by, same thing as before, vertical lines around B, and is defined by, once we put vertical lines around this, not the hooks for a matrix, this means to do the determinant. This one is much longer, but there are shortcuts to it. I'm going to show you the shortcut rather than actually going through this whole process. So here it is. We have to do A times E times J. Then we're going to add on BFG. So AEJ, BFG. Then we're going to add on another one, CDH. And we have more, minus GEC, GEC, minus HFA, HFA. And the last one, finally, minus JDB, JDB. Which might look like it's super random in how you put these letters and stuff together and how you're going to remember this, but I'm going to show you a shortcut to make it quite simple, I think. And we'll go to that next. So 3 by 3 is obviously a lot harder than doing a 2 by 2. So here's a shortcut. What I'm going to do is we're just going to pretend that their equal sign is not here. To do the shortcut, all you have to do is you're going to take this block of letters or numbers, and we're just going to rewrite them beside it. So the same exact thing. I'm going to write it right beside it. I'm going to do A, B, C, D, E, F, G, H, J. And so the way you do this to get the same exact answer is we start with AEJ. We're going to make diagonal lines. I'll show you. See here, see the first one is AEJ. It goes right down the diagonal. We're going to make a diagonal line. I'll highlight it. AEJ. Oh, come on. AEJ. And then we're actually going to do this 2 more times by making diagonals. So watch. I'll highlight them. The next diagonal would be BFH. Oh, I'm sorry. BFG. Messed that up. They're not perfectly lined up, I guess. BFG. Should be moved over a little bit. Plus BFG. And then we have one more diagonal with 3 letters here. CDH. There's CDH. It's probably better if you line them up a little bit better so you can see the diagonals. So once you have those 3, that takes care of the 3 that get added together. Now we have to do the ones that are subtracted. So if you look back here, we took care of these first 3, but now we have to do these last 3. So where does that come from? Well, GEC is the next one. So now we're going to start doing diagonals, but now it's going to go this way, up and to the right, GEC. So let's highlight a different color. We'll do, how about red? GEC. Now when you go this direction, we have to do subtraction. So it goes minus GEC minus, what's the next one, if I can get this right? Does it go HFA? Hope so. There's HFA. And there's one more diagonal here that we're going to do. JDB. Right here. JDB. There's the last one, JDB. So you don't have to actually memorize all these different combinations. If you rewrite the same matrix right next to it, and you got to remember, you're going to start with diagonals. You're going to do a diagonal 1, 2, 3. They're all positive, plus signs between them. And then once you start going this diagonal, 1, 2, 3, they all have minus signs in front of them. And in the end, you will just get one giant number, whatever that might be. So we're going to try one. There's actually quite a few to do, but I'm not going to do all of them with you. And just use a calculator. That's the best thing to do. Use a calculator and put it all in and do it all at once. So I'm going to immediately use a shortcut and write the numbers right beside it. We have 2, -5, 1, -3, 7, -4, and then 0, -1, 8. Now I'm going to highlight the first 3. Hopefully I highlight it correctly. Use green. So if you go right down the middle here, the first diagonal, that's your first one to use. We're going to go 2, 7, 8. Then we do -5, -4, 0, 1, -3, -1. That's your combinations. So these are all positives, remember. So it's 2 times 7 times 8 plus -5 times -4 times 0 plus 1 times -3 times -1. We're already halfway done. Now I'm going to do all the minus ones. Diagonal goes up now. 0, 7, 1, -1, -4, 2, 8, -3, -5. I guess you don't have to write the last column there, right? We're not using that. But just might as well, it's easier to remember to write the entire thing out, I guess. So let's change colors here. Now we're going to do the minus one. So it's minus 0 times 7 times 1 minus, we have -1, -4, and 2, and then minus 8 times -3 times a -5. You can actually put the whole thing in the calculator and then figure out what the answer is, and then you're done. I think I'll just do each one individually and then see what we get. Two times 7 times 8. That's 112. I'll put underneath here. 112. This here is going to get wiped out times 0. That's good. Don't need to write that one. Also don't need to write the one down here. 0 times 7 times 1. That's gone too, right? So now we have less ones to do. 1 times negative 3 times negative 1. That's going to be a positive 3. Down here we have a negative times a negative, which is positive, times another negative. So that's going to be a negative 4 times 2, which is 8. And then the last one, negative, negative, positive, times another negative, so it'd be negative. Oh, this is negative 8 too. Yeah. And then, so this one we know is going to be negative. It's going to be 8 times 3, and then multiply it by 5. So 24 times 5, 120. Add them together. So we have 112 plus 8, I'm sorry, plus 3, minus 8, minus 120. Looks like I got negative 13. I will do one more. There's one with a fraction. That's not really that bad. So I'm not going to do that one. You guys can do that one. Let me move on to part C. Again, I'm going to use my highlighter. Oh, I should probably write them out first. Let's do that. We have 3, 4, negative 1, 0, 2, 9, 1, negative 6, and 15. And if you remember, we didn't actually use these last numbers, and we won't when you draw the diagonals. So you don't need this last column. So as we draw the diagonal, so we're going to do the positive ones this way. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then I'll do the neg ones later. Don't want to mix this up. So 3 times 2 times 15 plus 4 times 9 times 1 plus, oh, we have negative 1 times 0 times negative 6. That's going to be 0. I'm just going to simplify that. Let's do the minus ones. 1 to negative 1, negative 693, 1504. So now I'm changing this over to minus. Minus 1 times 2 times negative 1. Minus negative 6 times 9 times 3. Minus, look what happens here, 15 times 0 times 4. So this goes away as 0. That's nice. We actually have 6 terms, but they all went down to only 4 terms because we have 2 zeros here. We don't need this one. We don't need this one. Multiply every single one, and then add and subtract what you need to. All right, so we have 30. 15 times 2 is 30 times 3, so it should be 90. Keep going. Plus 9 times 1 times 4, 36. Now you gotta be careful with the minus signs now. Negative 1 times 2 times negative 1. These will turn to positives, so it'd be plus 2. This one also turns to positive, a negative and negative. 6 times 9 times 3. 162. Then final answer, just add them together. I think it's 290. And I'll leave D for you to do as well. B and D in the examples you guys can do. There's also some huddles, but you only have to do 2 of them. I'd like to wrap this video up because I want to get through the inverses and be done with it. Probably won't do all that either. Let's see. All right, inverses. Last thing. We're going to solve these equations by finding its inverse. So one thing that matrices don't have is it doesn't actually have division. we did multiplication of two matrices, but you cannot divide matrices. So the way around that is they use something called its inverse. So what ends up happening is that we multiply by something to get a variable by itself. So for instance, if you look at 5a equals 45, normally we just say, hey, just divide by 5 and you're done, right? However, we're going to write this a little differently. 5a equals 45. Instead of saying dividing by something, I'm going to say, what can we multiply by? So that way the 5 goes away. Well, dividing by 5 is the same thing as saying, I want to multiply by, maybe you've heard of the word reciprocal. So 5 over 1 is the same thing as 1 over 5 as a reciprocal. Not the same thing, but it flips them around. And if you do that on one side and do that on the other side, what ends up happening over here is that when you combine these two with multiplication, it crosses out and you just get 1 or just a. On this side, you actually do the multiplication here as well, which would give you 45 over 5, which is 9. So another way to think about it, rather than dividing, you can think about it as multiplying by its inverse. In this case, we talk about the reciprocal. It's the same idea. So for part B, we have 1/3 B equals 7. How would we get rid of the 1/3 with multiplication? We would multiply by the reciprocal. In this case, would be 3 over 1. Do the same thing over here. Then you get 3 over 3. They cancel out. Just B. Over here, you can put it over 1 and get 21 over 1, or just 21. All right, the last one, we have 4/3 C equals 8. We would be multiplying both sides by, flip those around, 3 over 4 times 3 over 4. And again, these will cancel. You end up getting 12 over 12, or just C, 1C. And then over here, you can get 24 over 4, right, which is 6. So they're doing the same thing, solve for matrix X, by multiplying by its inverse. It's the same kind of idea. But what they use is kind of a weird notation. They multiply this, if you're trying to get X by itself, you multiply this by the inverse, which looks like this. Little -1 on top. And so what they do, and we're not doing this, we're not going to be doing this multiple times, but we multiply both sides by this inverse matrix, which you don't know how to solve for right now, and we're not going to do it because it just takes too long to figure that out. But instead of dividing by anything, they multiply by something called its inverse, and it looks like this. So that way, when you multiply these two together, it becomes the matrix with just ones in them, or the identity matrix. And this side over here is just X. And then you have to multiply these two together, which you can multiply two matrices, with the dimensions and making sure it works. But what we cannot do is divide matrices. So this would actually stay like this for now, until you know what those matrices had in them. I wouldn't worry too much about this. We're not going to get too deep into solving matrices by multiplying by the inverses. We're just going to practice one little thing. We're just going to do one thing to determine, we're just going to check and see if the matrix has an inverse. And the way you do that, since inverses for matrices are much harder to find, some matrices have no inverse, so we're going to check to see if they have one. If a determinant of a matrix is 0, then the matrix has no inverse. So you go through all the work. If the determinant ends up being 0, since we know how to do determinants of some matrices, then we would say there's no inverse, then you can't actually figure it out to solve for X back here. So if you do the determinant of A and it's 0, then we know the original matrix of A has no inverse. So all we're really going to do is look at and see if a matrix has an inverse by doing the determinant. Here's an example. Check each matrix to see if it has an inverse exists. So when we do the determinant, we're just going to see if it equals 0. If it doesn't equal 0, then we know it exists, right? Because if it does equal 0, it has no inverse. So we're going to do the 2 by 2 one, which is really easy. We do 2 times 9. minus 6 times 3. So that would be 18 minus 18. There you go, equals 0. So that means inverse does not exist. And you do the other two the same way. For part B, you have to do the highlighting thing, right? You have to highlight the 3 numbers. You have to do that first and see if that equals 0. If it does not equal 0, then you say it does exist. I will do the last one and be done, because it's a little easier to do this inverse. We do 5 times 12 minus 4 times 15. So what do we get? 5 times 12 is 60 minus, what's 4 times 15? Also 60. So this one would be another one that means the inverse does not exist. You're going to check and see if part B also comes out to be 0. And that's as far as we will go as far as talking about inverses and stuff for this chapter. We're pretty much done with this chapter, since this will be the last lesson we do with matrices. And when we come back, we'll do something different. And so you're going to go through, finish B, backwards through, and do 1 A and B for the huddle. We skip 2 pieces in the example, do those, and there's only 1 huddle left with 3 problems. And actually not too much. You can skip the warm-up if you'd like. And that's it.